Heat is also transferred during phase changes. However, during a phase change, the temperature remains constant. So we can't use a delta T equation to calculate the heat transferred during a phase change. However, if you think about a phase change, so think about solid water turning into liquid water, just think about solid versus liquid. One of the ways that we talk about solids, liquids, gases are movement of molecules. And you could imagine, you could picture molecules in a liquid moving faster than molecules in a solid. So it got energy. It got a type of kinetic energy that is thermal energy, but the temperature doesn't change. So let's look at how that happens. We will talk a lot about phase changes when we get more into intermolecular forces. However, since we're talking about things like delta H, there is a delta H associated with phase changes that we should look at. Just write some definition reminders. It's vaporization when we're going from a liquid to a gas. It's condensation when we go from a gas to a liquid. And we have values. Now, we're usually just given one value. So at 100 degrees Celsius, which is the boiling point of water, to go from liquid water to water as a gas, the enthalpy of vaporization is positive 40.7 kilojoules per mole. This is a published value, something you could look up or something I would give you. At 100 degrees Celsius, if you want to go from water as a gas to water as a liquid, the amount of energy that's given off is negative 40.7 kilojoules per mole. And this is just called the enthalpy of vaporization still. So the phase changes, you'll be given a value for one direction of that phase change, and you will need to know when to use the opposite sign. So pretty much like if you're going from a solid to a liquid or a liquid to a gas, those are going to be positive values. You have to put in energy to get those molecules to move as quickly as they need to move for the state that we're talking about. And then a gas to a liquid, liquid to a solid, you're going to give off energy. The energy that's contained in those molecules and how quickly they're moving has to be given up somewhere so they can slow down and turn into the other phase. Now, the temperature piece, right, when water is boiling, so going from a liquid to a gas, it stays 100 degrees the entire time. So when you do a phase change, right, there's a whole process. You have to heat it up to the temperature, or you have to take water and heat it to 100 degrees. It then stays at 100 degrees while turning into a gas. So that sample of water is going to be 100 degrees. And if you measured the temperature of the gas as it is boiled off of this water solution, that water as a gas is 100 degrees. So there's no temperature change. Every bit of energy is going into changing the phase. Right, so we've mentioned the other phase changes. We call it fusion when we mean melting. So that's a solid to a liquid, because the opposite of that is freezing, going from a liquid to a solid. For water at 0 degrees, to go from a solid to a liquid, the enthalpy of fusion is 6.02 times, not times anything, 6.02 kilojoules per mole. So to go from a liquid to a solid, so to freeze, water has to give off negative 6.02 kilojoules per mole. You can also have a solid to a gas phase change. We call this sublimation when it goes from a solid to a gas. So the opposite, if it goes from a gas to a solid, we call this deposition. And dry ice is a good example of this. So dry ice, right, it gets the like fog above it. That is just a solid piece of carbon dioxide turning into carbon dioxide as a gas. All right, so let's calculate some heat to melt ice. We're going to calculate the amount of heat required to melt 237 grams of ice. If we're melting, we're talking about enthalpy of fusion, and we're going from solid to a liquid. We have to put in energy. So my enthalpy of fusion should be positive. Except that this is in kilojoules per mole. I have a mass of ice, so we're going to have to do some conversions here. So this 6.02 kilojoules per mole enthalpy of fusion, it's still an enthalpy, and you saw it. You saw a reaction for melting. We're going to use this like a conversion factor the same way that we did when it was next to the other type of reaction. Officially, if you like to have equations, the heat for a phase change is the number of moles times the enthalpy for that phase change. So starting with 200 or 6.02 kilojoules per mole, if I multiply this by however many moles of ice I have, then I will have the value of heat in kilojoules. I need to convert this into from grams to moles, so I need to know/remember that ice is water to find the molar mass. And in the end, this gives me 79.3 kilojoules of heat. So taking solid water at 0 degrees Celsius and turning it into liquid water, I have to put in 79.3 kilojoules. And what this gives me is liquid water at 0 degrees. So what that means is that if I am going through a phase change and changing a temperature, I have to do it in steps. So let's say that I wanted to go from solid water at 0 degrees to liquid water at room temperature. First, I have to put in the amount of heat needed to melt the ice. Then I have to put in the amount of heat needed to warm the water. And you will see many more stepwise like this as we go into other examples.